Okay, so today we are going to review, but the test is until Friday. So we're going to see what you got, what you didn't get, and the test is Friday. The test will only cover the material that is on this review sheet. We are not going to review for 4 days. I'm going to do something else, word problems with read problems that are word problems, okay? And then I'll just give you I'll quiz you on that separately. Okay, so this is, bless you. I made it Friday, that way if I have my extra help on Thursday, if you still need extra help, you can come. Okay, so tonight, as far as homework goes, you know, some people still need more practice on this, so I gave you just a little worksheet, just extra practice. That'll be fun for you. But what I want you to do, I should have had you do this while I was walking around. Oh well, we'll pretend you did. Average value of g of x. I want to go over what you need to know. So if you have a function g of x and you want the average value of that function on the interval from a to b. Jillian? Cameron? It's a to b. All right. Yeah, the average value of g of x. So it takes on different y values between x equals a and b to get the average value 1 over b minus a times a definite integral from a to b. That's the mean value theorem. Average rate of change of g of x on the interval from a to b would be, Amanda? It's g of b minus g of a over b minus a. So that's just the slope formula. Okay, that's the slope between 2 points, which is just the slope of this angle. Now, here's a fun one. When you want to take the derivative of an accumulation function, and I made the lower limit b of x for bottom and the upper limit t of x for top. Fun? Yes. How do we take the derivative of the definite integral b of x and t of x of f of t dt? And Karen, what would we call that derivative? What do you think we should just call it, just so I can write something? Yeah, let's call it t prime of x. Nice. Multiplied by f of t of x. So we plugged it into. How do you know that? That's crazy. It's just crazy. So when you want to take the derivative of an accumulation function, the second FTC, derivative of upper, so we call that t prime of x. Multiply that by what you get by when you plug in the upper limit of integration in for the t. So derivative of upper, plug in upper, minus derivative of lower, that's the b prime of x, plug in lower, that's the f of x. So everywhere you would see a t, you'd put in the b of x. And on the review sheet, I think it was 5 through 8 was that type. You only do this when you're taking the derivative of a definite integral from some involving an x. Okay? Now, we've also seen in this unit, if you want to get f of b, and you happen to know f of a, you're given f of a, some other y coordinate somewhere else, what would you have to add to that to get f of b? Oh, Emily's, yep. Yes. When you add the definite integral of the derivative of that function from a to b, you add the change in that function from a to b. That's a lot. How are we doing so far? A1 since day one. Does that mean something bad? Okay, good. If I repeat things, I really should be careful before I repeat things you guys said. Okay, now let's say we're given a graph of f prime along with some areas that are enclosed between the graph of f prime and the x-axis. And we're asked to find the definite integral of f prime of x from a to b. Take a look. minus the area below it. What would you get for that? It is 1. Because the area above between A and B, and notice I only do this when A is less than B, so the area above is 2 plus 4, otherwise known as 6, minus the area below is 5. And 6 minus 5 equals 1. Now, this ought to be interesting. Without looking at any notes, see how much, you got to try things every once in a while without looking, or else you start to think, yeah, I know this stuff, because you're always looking, right? So try to come up with this chart. See what you remember. It's not being graded. Who cares? But put down what you know. Okay, who can do it? Hey, go on up. Let's see what you got. No, you want to. You can go in. Go on up. Yeah. Whatever you want to put up, and then so if you miss something or get something wrong, someone will come fix it. Yeah. For a dog. It's adorable. I think celebrities name their kids that. I think there's like some celebrity that named a child. That's nice. Well, for you kids at home, it's very exciting right now. Audrey's putting up the chart without looking at anything. Oh, I'll help you with that. Oh, you got it. Hey, kids with the names, have you done this? You did? All right. It's good so far? So far, Audrey's doing a great job. Oh, this is pretty good. She's up there with no notes. She's just doing it, right? And that's how you really need this memorized like this. So you can read it. Oh, she did a great job, right? Right. And you guys have realized that it's so important to know this. What about you guys? Did you get it right? Yeah. Okay. All right. So what we're going to do then today is we want to go over the answers to the review sheet. I gave them to you. I will say I think it's either 9B or 10B. Stuff. I think the interval that I gave on the worksheet, I think I said, was 10. If you look at question 10, I say where on the interval from 1 to 8 is it decreasing? It should have been negative 2 to 8. So you might have answered it just on the interval from 1 to 8. We'll get up to that in a minute. Oops. Okay. So let's start out with questions on the first page. So we had average value and average rate of change for the first 4. Questions on the average value versus the average rate of change. So it's questions 1 through 4 in the review sheet. I don't have the answers here. You have them. Yeah. No? Yes? Number 8. Okay, So with the second FTC, derivative above, oh, okay. Is that what you have on yours? It's sine squared of 3x to the upper limit? Okay, good. All right, so the way we take the derivative of one of these, it's derivative of upper. Now, to take the derivative of sine squared of 3x, you would want to rewrite it as the sine of 3x squared. Right, that makes it easier to apply the chain rule. So derivative of upper, we're going to have the 2, applying the chain rule, sine of 3x to the first. Next layer is the sine. What's the derivative of the sine of an angle? Cosine. Keep the angle the same. And then the innermost layer, 3. So you could rewrite this all as 6 sine 3x. So far we have derivative of upper. And we have to multiply that by what we get when we plug in the upper limit for all the t's. So now everywhere we see a t, we're going to replace it with a sine squared of 3x. Okay, so we're going to multiply this by tan of sine squared of 3x plus sine squared of 3x cubed minus 2. So far we have derivative of upper times we plug in the upper. Now we need minus what? Yeah, that's the big one. At least you don't have to simplify everything. Derivative of the square root of x. It's a derivative of the square root of x. That's x to the half, right? So 1/2 x to the negative a half, which is just 1 over 2 rad x. Okay, so 1 over 2 rad x, so derivative of lower, and then plug in lower. So we're going to multiply that by tan radical x plus radical x cubed minus 2. Second FTC. Is that all right, Emma? Any other questions on the first page? Well, because yeah, the derivative of x is 1, so you don't really have to write 1 times, right? And then the constant, yeah, it's the exact same concept. It's just that's the easiest of all of them because, like, if the upper limit's x, derivative of upper is 1, then you just plug in the x. And if the lower limit's a constant, you don't have to do that whole part because it's just 0. Yeah. Because it's minus derivative of lower, and if the lower is a constant, the derivative is 0. So you don't want to say minus 0 times something. Just you don't even have to bother. Okay. Right. So now we're moving on to. Yeah. Yes. Yes. Okay. Let's see. Number 7. Yes, correct. Yep, it's cosecant of x squared. So negative cosecant the angle cotan. Let's see. Yeah, this one, it would just be hard to do. I mean, on the average value of it, so you could write 1/5 the definite integral of 3 to the x dx. We actually do know how to integrate 3 to the x. It'd be 3 to the x over the ln of 3. I just thought that the numbers would get crazy because if we take the antiderivative, which is 3 to the x over the ln of 3, then we'd have to plug in the 3 and the negative 2 and subtract. So we could do it, but it would just be, the numbers would not be very nice to work with. Anything else on the first page? there are many expressions I could give you where you couldn't even do it, no matter. You just can't. You can't integrate it. Let's see. All right, so let's look at that number 9. I know this was hard to read, and I tried to remember to tell you guys. This is from 1 to x. So h of x is the definite integral from 1 to x of f of t to t, and it was kind of hard to read that part. So the first thing with one of these is you get the derivative. So doing what we just did, what would the derivative be? Well, derivative of upper, plug in upper, minus derivative of lower, so it's just going to be f of x. Whenever it's a constant to x, it's just going to be f of x. So what we're looking at, yeah, it's a graph of f, but that's also equivalent to h prime. So you realize, okay, this is a graph of h prime. They are equivalent functions. So if they ask you to find h of a number, you have to use the definition. H of 0 is a definite integral from 1 to 0. How do you get the definite integral from a graph? Yep. Yeah, use the areas. Now the only thing is that if you take the definite integral from 1 to 0, the lower limit's greater. So you could switch them and put a negative out front, or just do area below minus area above. That's the same thing. You just want to switch that. But to get h of 0, that was a definite integral. You plug in the 0 from 1 to 0. So anytime you want to get a value of h, you're going to have to use areas. And the area, negative 1. Ooh, you got a trapezoid. What's the area of a trapezoid? 1/2 sum of the bases. That's the height. Okay. So for the area of this trapezoid in here, 1/2, the bases are the parallel sides. Oops. Whoa. 1, 2, 3, 4. All right, that was a little off. Plus 2. So sum of the bases, the height would just be 1. This guy's just 3. Do I have the answer right on there? Okay. Just remember seeing that number. So h of 0, what is it going to be? It's a definite integral from 1. Oh, it's 1 or negative 1? Oh, it's 1. I went the wrong place. That's why I wasn't thinking it was. Okay. 1 to 0. 1 is over here. Positive 1. So here's a triangle. What's its area? 1/2 base times height. 1/2 1 times 2. So that's just 1. So if the definite integral from 0 to 1 is 1, what's the definite integral from 1 to 0? Negative 1. So you have to actually plug the number in to get a value of h. What about to get a value of h prime? You look at the graph. H prime of 0, you just read the graph. What about the second derivative? Okay, it's the derivative, which graphically means slope. So you look at the graph when x is 0 and look at the slope. Well, the slope at any point along the line is going to be the same. So you just figure out the slope of this line, and it's negative 2, right? Because if you look at this line, it goes down 2 over 1. So you're only looking at a graph of h prime, but you can get values of h through the definition, using areas, and values of h double prime through the slope. I should just take questions from you guys. Questions that you have on this one or TED. Yes? Well, just from a graph, that's the only way is slope. So, yeah, but you pick any 2 points. And I'm not going to ask you what is the second derivative. I would never ask you, like, over here, because you can't just guess what that is, right? I can only ask you what is the second derivative if the first derivative is linear. So you pick any 2 points on that line. Yeah, change of y's over change of x's. Oh, I'm sorry. I thought you meant like Yeah, oh no, like in other words, pick any 2 points on the line, okay, and just take change of y's over change of x's. And that's how you get the -2. Yep. Okay, other questions on this? Yes, John. Part B, they ask, how many zeros does h of x have? When you're asked for how many zeros, how many roots, how many values of x make the function equal 0? So they really want to know, remember h of x is the definite interval from 1 to x. We want to see how many values of x is the definite integral from 1 to x equals 0. Well, what's an obvious one that's going to make a 1, right? So you know that x equals 1 is a 0 of that function because it makes the whole function equal 0. And then if you look at the graph, you ask yourself, are there any other numbers, if I put them in here, and again, you calculate a definite integral area above minus area below, will you get 0? That's how it's given, but it was kind of blurred on your paper. Has to be given. My graph go? Oh, I went too far. I just went too far. Okay. So you know that h of 1 equals 0. Okay. Well, you want to know, are there any other values of x such that if you plug it in here, you also get 0? So if you go this way, you take a number greater than 1, will area above minus area below ever be 0? No, because all the area is below, right? So look at starting at 1 going the other way. If we're moving left, no, right? The amount of area is all above the x-axis. So you get to -3. But then even if you go further, yeah, okay, there is area below, but not enough to ever balance out. You're looking for where the definite integral from 1 to x equals 0. So just 1. Now, if there was a point where starting at 1, if you move left or right from 1, that the area above was equal to the area below, then it would be 0 again. Other questions on here? It could be this one or 10. Yes. Okay, good question. So you're looking at a graph of g prime, and you're asked to come up with an explicit equation for g on the interval from -1 to 4. So you have to start out with writing the equation for what you're looking at, g prime. So that's the first thing. So let's take a look at that graph on the interval from -1 to 4. So it is linear, or else I can't ask you to do this problem. But if you look at the graph of a line, you got to be able to write the equation of it. Right? So we're going to write an equation for g prime. And there are two ways to write the equation of a line. Slope-intercept and point-slope. Point-slope will always work. Slope-intercept works if you happen to know the y-intercept. So just for practice, I'd rather use, even though you can see the y-intercept, I think we should use point-slope. Okay? So to write the equation of this line, we just have to figure out its slope. Like when I move on here, I lose it. Okay, so forget about all these numbers. So to get the slope, and I was a little off when I was drawing this thing, I think. And I was trying, I think I labeled the points on yours. You pick any 2 points on the line to get the slope. So what is the slope of this line? 1, right? If you pick these 2 points, you do change of y's over change of x's, you get 1. You could. All right, so we know the slope is 1, and let's pick a point on the graph. So we can pick any of them, but I don't want to use the y-intercept this time. Let's pick a different one. 1, 2, okay. That's 3, 2, it's supposed to be. So we'll take the point 3, 2. We're going to get the same equation no matter what point we pick. So to write the equation of a line, it's y minus y1, which would be 2, equals the slope, 1, times x minus 3. Now let's solve for y. So if I distribute the 1 and add the 2, we have y equals x minus 1. See, I would have got that if I just used y equals mx plus b. If I used b was negative 1. I just want to show you that you'll get the same equation no matter what point you pick on the line. So the equation of the derivative, what we're looking at, g prime of x equals x minus 1. Now, we can get g of x. So since we know that g prime of x on that interval is equal to x minus 1, what do we do to that to get an equation for g of x? It's g antiderivative, yep. What's the antiderivative of x minus 1? X squared over 2 minus x plus c, right? So x squared over 2 minus x plus c. Now, we have one more thing to do. We have to figure out what c is. We need to use a point on the graph of g, not g prime, so don't take a point from the graph you're looking at, right? Now, somewhere along the way in this problem, we must have solved for different values of g. It has to be an x value between negative 1 and 4. Oh, yeah, they gave us negative 1, 0. We can use it. If not, I'd have to look to see if I had another one that I figured out using the areas. Okay, so we'll use the point negative 1, 0. That's the point on the graph of g. Look at right up underneath. Yeah, you definitely would need that. So if we put in 0 for g of x and negative 1 for x, that would just be half plus 1 plus c. C equals negative 1.5 negative, okay. C equals negative 3 halves. So now we can write the equation for g of x. So g of x is equal to x squared over 2 minus x minus 3 halves. So when you have to come up with an equation for a graph you're not looking at, start by writing an equation for what you have in front of you, because it'll be linear. I won't ask anything else. Take the antiderivative of it, solve for c using a point on a graph of g, not g prime. Well, no, you don't have to look at that part of the graph of g prime. What you have to write, anytime anyone asks you to write the equation of a tangent line to a function at a particular value, you want to start with the point slope. So it's y minus, how do you get your y1? Yeah, so that'd be g of 5 equals, well, I'm going to write this and then I'll answer your question. G prime of 5 times x minus 5. For g of 5, oh, no, you don't have to do that. You just have to use the, to get g of 5, you would take the y coordinate they gave you. What did they give you? G of negative 1 was 0? So you take g of negative 1, because that's 0, you know that, plus the change in g, which you get by integrating the derivative from negative 1 to 5. No, you like that. Now, remember you were telling me, you said, I just want to let you know, Miss Bark, that I like doing this, but I'm going to say I don't in class because the other kids don't think that's cool. Yes, Gina? Oh, for that point that we use, we can pick any point on the graph of g prime. Pick any one you want, and when you plug it in into the point slope and you get y by itself, it's going to be the same equation. So you could pick another point, but do you see that x, there's a point 3, 2, right? Any point on the line. To write the equation of the line, you just need any point in the line and the slope. You'll always get the same equation. 8. So, okay, and then for this one, so the definite integral from -1 to 5, you got to look at the graph of g prime and do area above minus area below between -1 and 5. So you're saying if you had done this part first to get g of 5? Oh, you did another separate one? Oh, who thinks that's crazy? Okay, anytime you have to get a value of the function, not the derivative, which is what you're looking at, you're going to need to use areas. So you're going to have to get all the areas for these problems anyway. So it's not like, you can just skip it for one part. So guys, really, if you didn't get to it over the weekend, because I'm moving on to word problems tomorrow, you got to make sure you're studying this throughout the week, right? Anytime you have to get a value of g, like the actual function, and you don't have what the actual function is, you only have a graph of the derivative, you have to use, oh, are you saying when you have to use this one, this thing? Okay, the accumulation functions, you don't have to use it. If I tell you that g of x is the definite integral from 3 to x of whatever, okay, of f of t dt, if you want g of 7, you just pop in the 7 and you do that. Yeah. Okay, but if they don't tell you, if they just say, hey, here's a graph of the derivative, they have to give you a point to start with, then you have to use this one. Oh, I chose a different point? Oh, no, yeah, no, I had to get g of 5. To get g of 5, you got to take g of -1, the y, that's the point they gave you. They told you, and add to it the change. If you look at yeah, if you go from, look at the graph from -1 to 5, tell me what the area above the x-axis minus the area below is. Oh, you got 6 minus 1? So that, and I'm, no, you wouldn't be wrong, but you could only do it in this one because that happens to be linear. Okay, but if it wasn't, if it was part of a semicircle or part of a circle, then you have to, yeah. I think you should get used to it because your way's going to be a lot more work. So from -1 to 5, let's figure out the area. So you must have had like a little problem with the area. I guess I should stop the recording. Hey, people, yeah.